Yes, welcome to lecture Flexible AC Transmission System and Power Quality. In the previous lecture, it has been discussed the different type of FACT controller and their control attributes, and what are the major application of FACT technology in the HVAC system. So now we are going to discuss comparison of HVDC and FACTs. So definitely the HVDC technology and FACT technology, they are complementary to each other. It is quite opposite to each other. Each system has some advantage and disadvantage depend upon the say situation, their geographical location, and amount of power to be transmitted. Now, HVDC is not a grid network because it is not a AC system, whereas the HVDC can be connected or it may interlink between two systems of the different frequency. So this is a major advantage. Whereas HVAC system or the FACT technology we are using in the EHV system, extra high voltage AC systems only. So now we see one by one what are the different between the HVDC, where we are going to use HVDC and FACT technology in the transmission network. So there are different type of transmission networks. One is the submarine cable, long distance overhead transmission line, which is the usual one. We look number of transmission line spread over the country. And underground transmission, that is underground cable, 132 kV line, 220 kV lines. And next is the connecting AC system of the different or incompatible frequency. So this is the connection of two area or two power systems area, which has a different frequency. It may be 60 Hertz and second may be a 50 Hertz. So it is useful for interconnection of grid. It may be as a national level, it may be a national level, it may be international level. Okay. So we will start from the submarine cable. Submarine cable, the cable which is laid through the water. It may be from the say big river, or it may be from the say sea and all these things. What is that? When we are using the cable, it have a capacitor, more capacitors, and it has the charging current. That is the more important for the charging current. So when we are using AC cable, either it may be underground cable, it may be a submarine cable, but it handles or it draws more charging current because of the capacitance. Why capacitance? Because the three conductors R, Y, B, it is very near to each other and it is insulated with the help of some insulation. So it acts as a continuous capacitor over the transmission line. I just give the example for the cable capacitance over this one. During the lockdown period, entire our campus is off, means the hostels has zero load, isn't it? Hostel number 1, 2, 3, whatever it may be, that the load on the hostel number, all hostels are zero. Whereas the underground cable, it deliver only the charging current, and because of charging current, even all the capacitors, whatever the capacitor which is connected in the system, say for example, in the system there are a number of feeders are there for hostel number 1, boys hostel number 1, boys hostel number 2, and there are a number of feeders, and one more feeder, it is connected to the capacitor. That is a APFC, automatic power factor controller. It has been observed that even the automatic power factor controller is totally off, means not a single capacitor is in the working condition, but still the power factor is unity, and it is due to the capacitor charging because of the cable charging current, and it is a leading current. Okay, so because of this one, the cable carries a large amount of charging current, and because of this current, even under no load condition or even a small load condition, the cable become overloaded. For example, the full load current capability, or say full load current handling capacity of the cable is 100 ampere, and because of large amount of charging current, the cable become overloaded, or even at a small load condition, the current in the cable is equal to the its rated current. So we can say that the submarine cable, where it is not possible to connect, because why it is not possible? Because the cable is laid through the water. Cable is laid through the water, and it is not possible to connect the capacitor. It is not possible to connect the FACT devices, because to connection any, it may be at the midpoint of the transmission line. If you want to connect some capacitor, or if you want to connect some FACT controller, we need some land, isn't it? And as the cable is laid through the water, it is not possible to connect some FACT controller. And here, this is the drawback, or this is the limitation of FACT technology to use in the submarine cable, isn't it? So for the submarine cable, which is possible, is the HVDC is is appreciated, where the submarine cable length is large. Generally, the distance between the overhead conductors, which may be say 30 kilometers, which needs some FACT devices, whereas in case of in case of the cables, it is only from 15 to 20 kilometers. So we cannot lay more than 15 kilometer to 20 kilometer submarine cable without any FACT technology, without any FACT controllers are there. So this is the limitation of FACT technology in the submarine cable, and we have to switch toward the HVDC system, because HVDC system, the length of the cable or the length of the transmission doesn't matter. What is that? Say, for example, it is because of this one. The HVDC is mostly because of the economic point of view. It is seen that, say, this is in the kilometer length of the line. Length of line, you might learn this one in kilometers, and this is the relative cost. Relative cost for the EHV system. As the length of line go on increasing, the installation cost is go on increasing. So here it is, the installation cost is go on increasing. Whereas for the, this is for the EHV system, EHV AC system, isn't it? We can use here FACT technology for improving the power handling capacity of the transmission line, controllability, as well as the say stability point of view. Whereas this is the, say, HVDC. This is HVDC. Why it is HVDC? The cost is very high at the initial, because it needs some inverters and converters from the both end, from the sending end as well as the receiving end. So the installation cost for the transmission line for the HVDC is very high. But this is the break-even point, and this break-even point is nearly 800 kilometers. So if the length of the transmission line is more than 800 kilometers, definitely HVDC is preferred as compared to the EHV system, isn't it? Now it means that the HVDC is most useful for the long transmission line. So where the cable, submarine cable, which needs some FACT technology or FACT controller every 30 kilometers over there, and it is not possible to erect the FACT technology or FACT controller in the sea or some into the water. Therefore, definitely here HVDC system or HVDC transmission system is preferred as compared to the FACT technology. Okay, this is one. Long distance overhead transmission line. Long distance overhead transmission line, definitely when there is a overhead transmission lines are there, it means that we are using some kind of poles. There are some kind of poles, and over this kind of poles, we are using the transmission conductors. So here the distance does not matter. The distance may be long, because it is possible to erect a FACT controller. Here we can erect a FACT controller because land is available, and hence here the cost of overhead transmission conductor or transmission system is smaller as compared to the HVDC. As compared to the cable, because in case of cable we have to consider the charging current. And as soon as the length of the submarine, length of the cable is more than 30 kilometer, it is not possible to transmit large amount of power. So overhead transmission line is EHV system is very useful, and EHV system with conjunction with the FACT technology, definitely our objective one for the control over the transmission parameters, transmission line parameters. Second is the stability, and the third is the power handling capacity. Definitely it can be increased power handling capacity. So by this overhead transmission line, where it may be, if the length of the transmission line is say around 1000 kilometers, definitely we will use EHV AC system in conjunction with the FACT technology. So whereas if the transmission line is more than 1000 kilometers, it may be at 2000 kilometers or 1500 kilometers are there without any toppings, definitely HVDC system is good. Okay, so here this is the second point which we have considered. Third is the underground transmission line. Underground transmission line, it means that we are using some cables. So do not confuse, here also the cable and here also we are using the cables. This cable from the underwater, this is from the underwater, and it is only from underground. So underwater, what is the drawback? Because of the water, it is not possible to erect the FACT controller, isn't it? Because it needs some land, it needs some station. So it is not possible into the say water. Therefore, submarine cables, HVDC is good. Whereas for the underground cable, definitely as it is underground, we can erect some transmission, we can erect some FACT controller over the ground. So it may be like that. Say if suppose the cable is underground, this is underground cables are there, isn't it? Total underground cables are there, but we can erect here a FACT controller over this one. So here it is possible to use the underground cables for the EHV transmission system. So here we can use the EHV AC transmission, definitely. But the distance between FACT controller, say for example, this is the transmission network. This is the transmission network. We are using FACT controller at the center of transmission line. So this length of the transmission line is 500 kilometers. Okay. Whereas if you are using the underground cable for the EHV AC system, definitely we have to use some more number of FACT controller in the entire transmission line, because there is a limitation of the underground cable since it carries the charging current, isn't it? So this is the difference between the submarine cable and underground transmission system. In underground transmission system, we have land, we have a say facility to erect the FACT controller, whereas in the submarine cable we does not find such facility to erect the FACT controller. Therefore HVDC system or HV or DC transmission system is quite good in this case. Now the next is the we can say that next is or one more thing is there. Okay, connecting AC system of the different or incorporate, or you can say that we can incorporate to different frequencies. Substations are there, and with the help of HVDC, it can be connected. So it will improve the stability of system. Or say for example, we can say that this is India, which is generating the power of 50 hertz. Somewhere it is in the Nepal, it is producing the energy at 60 hertz. I'm giving some example only. May possible in Nepal also 50 hertz frequencies are there. But we can connect the two frequencies area, with the help of HVDC. So HVDC is quite, with the help of HVDC, it is quite possible that we can connect two different area of the different frequency. But in EHV system, AC system, the frequency should be in the range of 57.5 hertz to 51.5 hertz or 52 hertz. This is the range over which the frequency, if there is a deviation in the frequency because of the active power, change in the sudden active power, it may come out from the synchronism, because we have a two type of channel, that is called as a PQ channel and PF channel. Sorry, this is PF channel and QV channel. Whenever there is a large or sudden change, or it may be change in the active power, this is the active power kilowatt, and there is a, we will observe some change in the frequency. Whereas when there is a change in the reactive power, kVAR, reactive power, it may be the capacitive or inductive reactive power, the voltage is going to change. So if you want to maintain the voltage constant, we have to maintain the reactive power, and if you want to maintain the frequency in the permissible limit, definitely the active power has to be maintained properly. So this is the some relative comparison between the submarine, between the HVDC and EHV systems are there.